parts say? So 2x is the same thing as 2 times the quantity square root of x squared. Oh my gosh. What is the square root of x squared? X. So I rewrote the x as the square root of x squared. Why? 1, it's fun, and 2, well, now we have our required format. The exponent on one of them is twice the other. Here this is a 2, here this is a 1. And something's being repeated. I'm just going around the circle here. Ooh, blue and orange. How nice. So for all of these equations, quadratic in form, you might need to rewrite it so you see something being squared and something being repeated. Whatever is being repeated, give it a new name. What do you want to call it? What'd you call it? So what's my new equation now in terms of b? So replace these highlighted guys with b's. 2b squared minus 7b equals 0. And right now, everyone should be reminded of that scene in Arrested Development where Lindsay says bees, and then Job thinks she says bees. It's hilarious. Bees? Love you, Job. You're hilarious. 2b squared minus 7b plus 6. How does it factor? Oh, by the way, will they always factor? Might you have to bust out a quadratic formula within this problem? But this one does factor. I'll give you a hint. To b minus 3. Good. So what does this say about b? What does the first factor say about b? b equals 3 over 2. And b equals 2. But did we start with b? No, you don't mess with b. Instead of b, we got square roots of x. So square root of x equals 3/2. And the square root of x equals 2. How do we solve for x? You square both sides, because these are now radical equations. So if I square both sides for the first part, on the left I would get x. On the right, what is 3/2 squared? 9/4. So that's one answer. For the second one, if I square both sides, I get x to be 4. Oh, that's okay. You should technically check them. I think both of them work. All right, what are you thinking? So what is getting replaced? What expression? X to the 1/5. So we could rewrite this as 4 times the quantity x to the 1/5 squared plus 5 x to the 1/5 minus 6. So we see our something being repeated. Oh gosh, we are going pink. Oh, that's really pink. We see our something being repeated, and the exponent on one is twice that of the other. The fifth root. That's fine. Okay, so give x to the 1/5 a new name, q. All right, good idea. Let's use q. So what's my new equation? Four q squared question. 4q squared plus 5q minus 6. Guess what? It's factors. Four q minus 3 and q plus 2. Let's check it. Looks good. That is prerequisite material. So what does it say about q? And good. Did we start with q? No. What do we start with? To the how do we get rid of a 1/5 power? Say it correctly. Raise it to the 5th power. There you go. What is x to the 1/5 to the 5th? X. What is 3/4 to the 5th? Does that reduce? No, because 3/4 doesn't reduce, so any power of it won't reduce. All right, what is negative 2 to the 5th? Negative 32. All right. E. I'll use that color. What are we replacing? X to the what? X to the negative 1. Good. So give me a letter. Good, that's what I was going to pick. Good job. We'll go light blue. So we have 18. Sorry. 18u squared plus 27u plus 10 equals 0. How does 18u squared plus 27u plus 10 factor? So this implies that u equals, good. And then the second factor says u equals negative 5, 6. Hold for applause. That's good. But we did not start with u. We started with x to the negative 1. x to the negative 1 says take the reciprocal. So if x to the negative 1 equals negative 2/3, what does that say about x? Negative 3/2. Good job. And if x to the negative 1 equals negative 5/6, then x equals, good,